Hello, hello. Okay. One second, I'm just going to check. I think it is all good. I'm just waiting for the quick relay. But yeah. Okay, perfect. So we've got sound. Okay, we've got camera. We've got lights. So we can get started. So hello, I'm Ian, creator of crackmaths.co.uk, and this is part of the lessons that I'm doing at the moment, where I'm posting 4 live lessons a week on Mondays, Thursdays, and on Fridays. And so on Thursdays, what we're going to do is we're going to look through a past paper. We'll be looking through the first half, which is going to be the whole of the non-calculator section and a bit in this first 45 minutes. And then I'm coming back again at 5 o'clock, and then we'll look at what we haven't covered here. If you've got any questions, please feel free to help them in the chat. Right, I see. Yeah, please feel free to put them in the chat. Yes, this is a good question, Paul. How do you get things to sink in? It's a big one actually. So what you've kind of got to do, and I'll kind of go through it actually when I do this paper, is I'm going to try to you've got to always try to draw back to focus on what you know in a way without focusing too much on the math side of things. That's what I find is the biggest challenge here. It's almost that there's so much maths involved that you want to focus on that, but actually a lot of the times in the question we can kind of pick apart that. So let me get started and let me see how it goes. And if you've got anything there, I'll try to ask you questions in the way anyway that's going to help out. So okay, let's just have a look at this question first. I'll give you a moment to read it, and then I'll read through it as well. And then we'll have a look at how to do that. So right, okay, so I've just read through this question, and it says, Damon is a motorcycle racer. He takes part in 2 races over a weekend. 4,650 spectators watched the race on Saturday. This number is increased by 2% on Sunday. Increase 4,650 by 2%. Okay, so the key thing to remember is that this is a non-calculator question, and so we can't use any calculator methods here. But with any percentage question, the most important thing is to always identify what is your 100%, okay? So if I look here, we've been told the original value, so this is my 100%. So I know that 100% equals 4,650. Okay, so here we go. We've got 100% is 4,650. Now what I need to do is from here, I'm going to go down. Well, I can do it in stages. I can go down to 10% first, because I can divide both of these by 10. Okay, so if I divide both of these by 10, I'm going to get that this is going to be 465. Now, if this is 465, that's 10%, and that makes sense because if we think about something that's been broken up into 10 pieces, 1, 2, 4, 5, 6, 7, 8, it's always difficult to do this, 9, 10. So now, if the whole lot of this was the 4,650, each one of these sections here is the 465, okay? So that's like 100% broken up into 10 pieces. The next thing I'm going to have to do is I'm now going to have to get from 10% to 2%. So there's multiple ways that I can do this. I'm actually going to go to find out what 1% is. So I'm going to divide by 10 again. Okay, so, and that's going to give me 1%. So 1% is going to equal 46.5. So now if I know that 100% of the spectators was 4,650, 10% of the spectators was 465, 1% was 46.5. Now if I times that by 2, what I'll get is 2%, okay? So here we go, times by 2, times this by 2. Right, okay, so this isn't the easiest thing to times by 2 actually. So let's, well, we're kind of doubling it. So we can think of it in different parts. We can think of it as the 40, as the 6, and as the 0.5. Okay, so 2 times 40 is 80, 2 times 6 is 12, and 2 times 0.5 is 1. And then what we can do is we can add these bits together. So we get 80 add 12 is going to be 92. Add one more is going to be 93. So there we go. 2% is 93. And now we have to add this onto the spectators. So we've got 4650 add 93. I'm going to do a column method here. So the column method is going to be 0 add 3 is 3. 5 add 9 is 14. 6 add 1 is 7. And then we've got the 4. And that should be 4,743. So I'll write that here in the space. Now, I'm actually just going to double check what I've done on my calculator here, because it is possible that I've made a mistake and I just want to be sure. Obviously, you won't have the calculator for double checking your exam, but I'm just going to do that now to make sure I haven't told you anything wrong. So 4650 times 1.22. And that is all good. My calculator agrees. Okay, so there we go. The answer for this part A was 4,743. Okay. Right. So next page we've got here. So here we go. Oh, what went wrong there? 1 second. Okay. Right, 1 second. Stop share. Right. Where is it? Sorry about this. Aha. Here we go. Right. So here we go. We've got the question back now. So here we go. Part B says, I'll give you a moment to read this as well, actually, and then I'll read it out. So. Okay, right, so let's have a look. So it says here, in the race on Saturday, each lap was 2.678 miles long. Oh, pardon me. We're told that 1 kilometre equals 0.6214 miles. Round each of these two figures to 1 decimal place and use these values to estimate the length of each lap. Right, okay. There's quite a lot going on there. So, right. So I'm going to just focus on this bit to start off with. This rounding these to 1 decimal place. So 1 decimal place means they only want 1 number after the decimal place. So for this 2.678, we've got to decide if this is going to be better represented by 2.6 or 2.7. Okay, So this is what one decimal place means. It means one number after the decimal place. So if I look at these two numbers, 2.6 and 2.7, I've got to decide, is 2.678 closer to 2.6 or closer to 2.7? And the way that we decide is we look at this number here. Now, if this number here is 5 or above, that means we round up. Sometimes it's useful to have a picture of this, like a little arrow here. 5 or above, 5, 6, 7, 8, 9. 5 or above, we round up, okay? And then if it's 4 or lower, the number stays the same. So 2.678, the 7 is greater than 5, okay? So we're going to say that 2.678 is going to be 2.7 to one decimal place, okay? Right, now let's look at the next bit. So here we go, we've got this bit here, which is 1 kilometre equals 0.6214. So this is going to be either, remember we're looking at one decimal place, so we're looking at this number first. So this is going to either be 0.6 or 0.7. Okay, we never go lower because we've already passed the 6. So all these numbers are like 62, 63, so on. So let's look at this 2 here. Is this 5 or above? It's not. So we're going to say that 0.6214 is closer to 0.6. Okay? So we're going to say that's close to 0.6. Right. Now let's think about this question again, because I've already forgotten what it was asking. So I'm going to say that's 2.7, and I'm going to say that this is 0.6. Okay, so in a race on Sunday, each lap was 2.7 miles long. 1 kilometre equals 0.6 miles. Round each of these figures to one decimal place. Use these values to estimate the length of each lap in kilometres. Right, so basically, our lap is 2.7 miles. Okay, 1 kilometre equals 0.6 miles. So they want us to find out how many kilometres 2.7 miles is. Okay, so I'm actually just going to count up here. So 0.6 miles equals 1 kilometre. 1.2 miles equals 2 kilometres. Okay, 1.8 miles would be 3 kilometres. 2.4 miles would be 4 kilometres. Like, although it's a complicated question this is, but the maths that we're using here is quite straightforward. It's just a case of kind of sitting back and thinking about what's going on. Right, now 2.4 miles isn't 2.7 miles. So we need another 0.3 miles. Okay, now that's okay because if I know that 0.6 miles equals 1 kilometre, well, I can see that 0.3 miles is half of that. So that will be 0.5 km. So what I just need to do is I need to add on that extra 0.3 here. So what I'll get, that will be 4.5 km. So here we go, 4.5 kilometres. So that's what we've got there. So we've got the estimated length of the lap in kilometres would be 4.5 kilometres. Right, okay. So let's just quickly take a quick look at how we did that question again, just to quickly go back through that. So the first step that we did, and this would have got us 1 mark, would be the rounding. Okay, so we rounded both of these numbers to 2.7 and to 0.6. After that, what we had to do was we had to then try to make sense of the question. So the question was essentially how many kilometres is 2.7 miles? So what the most useful thing to do is to write this down, to write down our thing here. So we started with knowing that 1 kilometre is 0.6 miles. And then from that, what we had to do is we had to start kind of just counting up in sets of 0.6 miles. So I knew that 0.6 miles was 1 kilometre, which I put over here. Then from that, we knew that 1.2 miles was 2 kilometres. Then we knew 1.8 miles was 3 kilometres. 2.4 miles was 4 kilometres. And 2.7 miles, well, 2.7 miles we got by doing this bit over here, which was the 0.3 miles is 0.5 kilometres. And then we put that all together, and that gave us our answer of 4.5 kilometres. Right, I hope that's okay. Let's move on to the next part, okay? Right, question 1C. Okay, so I'll just leave you with a moment to read through this. Oh, 1 second. I'm waiting for my computer to catch up here. Right, so I'm going to read through this for a moment, and if you all want to do the same, that would be great. And then once I've read it and you've read it, I will come back and we can have a look at it together. Okay. My gosh, there's a lot of numbers on this. Right, where are we at? Right. Okay, so I think this one's actually okay. It's just that the numbers are all so long, it's quite difficult to read. But let's have a look at the start. So it says here that Damon and Ralphie each complete 7 laps in the race on Sunday. The median lap time for Damon is 1 minute and 17.924 seconds. This time is shown... Sorry about that. I don't know what's going on with this today. Right. Sorry, I'm just waiting for my screen to reattach. Okay, sorry about that. Right, here we go. So we've got here, Damon and Ralphie each complete 7 laps in the race on Sunday. The median lap time for Damon is 1 minute and 17.924 seconds. This is shown as 1 17 dot even 9.24. Okay, right, that makes sense. So this bit here represents minutes, and these bits here are the second. These bits here are the seconds. The range of the lap times for Damon is 4.812 seconds. Right, just to remind yourself, range is a statistics term, and it's for data, and it refers to the largest value minus the smallest value. Okay, so in a way it's kind of like you're thinking about everything from the top end to the bottom end. So it's like, this is the range of stuff. We go from large to small. Okay, and the range that they tell us is they tell us the amount of the unit that we're talking about, how big that is. So we know that the slowest race time for Damon was 4.812 seconds longer than the smallest. Okay, right. Interestingly, just to note about ranges whilst we're here, with ranges, you need to know why they're important. And ranges are important because they tell us about consistency. So range is all about consistency. So a large range means something isn't consistent because the data is spanning over a lot of places. A small range means that the data is consistent. Okay, so let's continue with the question. The next bit says here that we've got the table below shows lap times for Ralphie. So here we go. We've got 1, 2, 3, 4, 5, 6, 7 times here. And what can we see? Right, so we've got to calculate the median and the range for Ralphie and then make some comparisons. So I'm going to just number these in size order. Okay, so if I have a look here, I can see that the smallest one is going to be this one. So this is the smallest here. Then the second smallest is 16, this one here. The third smallest, we've got the 18, the 19, and the 21. Oh, so call that 7 here. Okay, great. So this is our... Right. I see. Right, my internet's not very good. Oh no! Right. Okay, sorry about that. I don't know what's going on with my internet there. Let me just maybe... Okay, right, so we've got our consistency back here. And so what have we got? So we put them in size order because we're looking for the median. So here we go, we've got the median. So the median's always the middle value. So the way that we can find the middle value is by doing the number of values that there are. So 7, add 1, and then dividing that by 2. So 8 divided by 2 equals 4. So the fourth value will be our median. So I can see that that's going to be this one here. So Ralphie's median is going to be 1 minute and 17.986 seconds. And then his range is going to equal the highest takeaway, the smallest. So I'm going to just do that over here. So that's going to be 1 minute 21.467 seconds. Take away the lowest time, which was 1 minute 16.008 seconds. Okay, I can do this like this because everything's lined up. 7 take away 8, I can't do. So I borrow from here. So that's going to be 9, 5, 4, and then 1 take away 6 we can't do, so I borrow 1 from there. So 11 take away 16, 11 take away 6 will be 5. 1 take away 1 will be 0. 1 take away 1 will be 0. So what we have here is that the range is going to equal 0 minutes 5 seconds 0.459. Right, so now we have got Ralphie's statistics. So his median is this and his range is this. Okay, so from here, let's now make our comparisons. So our comparison is going to be that the median is for Damon is here. So, right, so I can see that Ralphie has a higher median because we've got 986 here as opposed to 924. So Ralphie has the higher median, and Ralphie also has the larger range. Okay, so these are going to be my two comparisons. Okay, so my comparison one, they want your whole answer here. So let's write the median. Ralphie has a higher median of 1 minute 17.986 milliseconds and a larger range of 0.05.459 seconds. So there we go, we've got our comparisons, we've got our data, so that will be all of our marks for that section. Okay, let's have a look at 1D. So here we go. So 1D says, Damon drives along a straight part of the track at an average speed of 126 miles per hour. He completes this in 47.5 seconds. Work out the length of the straight part of the track in miles. Wow. Okay. Fine. So, right, we've really got to think here. So, 1 second. So, I know he's doing 126 miles in 1 hour. Okay. So, that's going to be 126 miles in 60 minutes. Okay. I'm just going to simplify this a little bit here. So half of 126 will be 62. So 62 miles in 30 minutes. I think I can simplify this some more. 31 miles in 15 minutes. Okay. Now there's 60 seconds in a minute. So 15, I'm going to do 15 times 60. So 15 times 60. Well, I can split this up into 10 times 6, add 5 times 6. So 10 times 6 is 60, 5 times 6 equals 30. So that's together 90. 1 second. Okay, but because it's 60 even, so that'll be 60, so that'll be 600, 600, 900. So we've got 31 miles in 900 seconds. Gosh. You know what? This paper, I haven't actually often done many NCFE papers, but this paper's really hard. Right. So, 900 seconds. So let's see if we can break this down. So we kind of want to get this to 47.5. We want to know how many miles he's doing per second. So well, So it's 3.1 miles in 90 seconds. $47.5. So we could half this. So half of 3.1 is 15.5. Well, it's not 15.5, it's 1.55. So we know that he does 1.55 miles in 45 seconds. Okay. But we've got to get that 2.5 somewhere, because this is here. So what could we do? Well, if we divide this by 9, what we get... This doesn't look easy, I'm afraid. Sorry, I'm making this look quite hard. But it's just trying to get through it. So if we divide this by 9, we'll find out how long he does in 5 seconds. So that doesn't go in. 15. So that goes in once with a remainder of 6. 65 divided by 9. 64 is... No. 63 is 7 times 9. So that goes in 7 times for a remainder of 2. And then that goes in twice with a remainder of 2. Okay, right. So 5 seconds equals 0.172 recurring miles. 2 seconds is going to be half of this. So let's divide that. 2.5 seconds will be this divided by 2. So there we go. So that's 0. That doesn't go in. Doesn't go in. 8, 1. Okay, and that goes in 6. Right, so 2.5 seconds is 0.0861 recurring. So, what we get, we know that this is 45 seconds. We know that he travels this bit in 2.5 seconds. So now what I can do is I can add these together. So 1.55, add 0.08611111. Okay, and that's going to give me 11111 6, and then 5 add 8 is 13. So we've got here, and then 5 add the 1 is 6. So that put that there. Then we've got 1. So the answer would be 1.631 recurring miles. Have they asked us to give that to a decimal place? Nope, they haven't. So there we go. That's that. So 126 miles per hour. Let's just retrace our steps, because this actually doesn't look right, does it? But let's go back. So 126 is 1 hour. So that's 60 seconds. Oh no! I did go wrong. Here. I halved 126 to get 62. Ugh, I was thinking to myself, this has gone on for too long. Okay, right, so this is one of the problems, is where you go wrong and you have to then... I should have known earlier that I'd slipped up, okay? So what I didn't do here is I didn't half this correctly. Now, I wonder how many of you spotted that. If you did, well done. If not, let me go back. Oh, this is so sad, but it's actually so good, because it means that this question is going to have been a lot easier. Okay, so half of 126 is 63 miles. Okay, so that will equal 30 mins. Oh my gosh. Right, then we can divide both of these by 3. Okay, which gives us 21 miles equals 10 minutes. Oh my goodness. So 21 miles equals 600 seconds. I can divide both of these by 3 again. 7 miles equals 200 seconds. Okay, now this still isn't lovely. Right, so then we get 3.5 miles is 100 seconds. Okay, which we could then say that 0.35 miles equals 10 seconds. Okay, so we're going to want 10 lots of this. So 10 times... No, we're going to want 4 lots of the 10 seconds. So 4 times 3.5, or 0.35. I'm going wrong all over the shop. Equals 2 times 0.35 is 0.7. That equals 1.4. Okay. So 1.4 miles. Then if we half this, 0.175. Yep. 0.175 miles equals 10 seconds. Okay. No, equals 5 seconds, sorry. Oh dear. And then, right, and then we need to half that again to get the 2.5. So we're going to have 1.4 plus 0.175. And then when we half this, we've got the 2.5. So let me just go down here to half that. I'm going to need some more space. 0.175 divided by 2. Doesn't go. 8, carry the 1. 2's into 15 are going 7 times with 1 remainder. 2's into 10 go 5. So then we've got plus the 0.0875. Add all these together, put in these zeros just to make it easier. 5, 12, 8, 5, 6. Here we go. So 1.6625 miles. Okay, still not lovely, but nicer than it was before. And I'm still... Right. Sorry about this, guys. Right. Oh, dear, man.